So the aim of this evening is to give you a good understanding of what the maths curriculum actually looks like, because it has changed, and the better understanding you have of it, it will help us, it will help your children. So the aim of the maths curriculum as they currently stand: people should be able to be fluent in the fundamentals of mathematics. First thing I want to say about that, fluency is not necessarily speed. That's a common misconception that people might have. It's not always about speed. It's about picking up concepts just quickly but efficiently and able to apply that into other areas, which we'll have a look at later on. The second one is reasoning, and it's the toughest one children find because, like many of us, I suppose, mathematically, if you're thinking that way, when you get to the answer, you've got the answer. That's it, I've got the answer, so why do I need to carry on? But the answer's only the beginning. So it's about what we do after we've got the answer that can really deepen the understanding, really deepen the learning that's going on in maths. Once they can do these two things, they've understood the concepts, they've understood and they can reason their understanding, then they can apply that into problem solving and apply it to other areas of the curriculum, or apply it to maybe a new problem in the same area. So those three steps are based, all of the teaching and learning in the school, in the curriculum, is based on those three things in maths. It's not just this fluency of being able to calculate quickly, or being able to do a column method of addition as soon as possible. It's not what it's about anymore. It's about these three things together. I really like this analogy up here, sorry if you can't see it. It's about the depth of learning that we go to. Now at the top, we've got a child who's just paddling in some water, so they're not ready to swim yet. They have the concepts at a basic level. When they're ready for it, they can then move on and they can start to snorkel. They can go onto the surface because they're starting to be able to realise those concepts, they reason around it, and they're able to start to apply it, make connections around the curriculum. And then we can do all that, they're ready to go diving. They can go under the surface, they can really look at other problems and put their knowledge to the test in other areas of the curriculum. So there's a quick example, and this is what you're going to see around the classrooms later on. It's about these type of tasks that we're doing with the children, that we're talking about. And so let's look at this. This is around a year 3 objective, being able to add fractions with the same denominator. We can do it what we call pictorially, where we have some pictures that can represent it. And once we know that there's 5 parts in the whole, we can add those up to find that there's 4/5. And when we have that concept at a basic level, then we can just go on to some harder fractions. No. They could go on to add 17ths, 20ths, 200ths, but actually we want to go deeper understanding into the actual concept itself. And here's what we mean by that. So this is a reasoning. Explain why the numerator changes in this calculation, not the denominator. And that can be applied to any fraction. 17ths, 25ths, doesn't matter. It's that understanding of the concept. It's not just being able to know that, get the answer, I'm done. It's how do you actually go into that greater depth of learning, how do you actually reason that? Why are we only changing the numerator, not denominator? And here's something that a child might come out with. If we're counting in fifths, just like we would count a counter or a coin, a fifth is something to count. In fractions, we put this number on the bottom where the denominator is. 1/5 and 3/5 added together is 4/5. Just like we would count 1 flower or 3 flowers added together. So they're putting their knowledge of other areas of the curriculum and making connections and linking and able to reason this. It's not just as simple as doing this quickly, as quick as they can. It's about going into greater depth. And later on, when they can do that, they might be able to apply that knowledge into a different problem. So how many addition number sentences can they make about what this might show as fractions? Can they make a subtraction number sentence? So we're not necessarily moving them on from a harder or harder numbers. We're really going to greater depth about the same concept. And that's the big shift of the culture that we are trying to create. It's not just we're going to push them on to something, to the harder numbers quickly. We're not just going to put them on to some harder fractions, in this case, quickly. What we want to do is really secure, concrete that understanding that they have through this process. So our fluency, our reasoning, and then our problem solving. Okay, and that's what you're going to see later on when you go into the classrooms. Okay, it will be lots of these activities which will show the three parts of the curriculum. Okay, homework. The way we've designed the homework is to support the learning that goes on within the classroom. It's been designed so that we don't just give it for the sake of giving homework. Homework needs to have a purpose. And the way we split it, especially in Key Stage 2, is that we give out the tasks, and then the tasks are then discussed in the lesson. Going back to the curriculum requirements, the aims, they need to reason, they need to explain, they need to securely understand what the concept is. So, to hit that part of the curriculum, we need to discuss about it in class. We need to know, what have you understood about that task? Let's bring it together back into class. What have you learned? What don't you know? What do you know? Is there a wrong answer? Well, great. How can we explain that? Is it the right answer? Okay, well that's just the beginning, like I said earlier. The right answer is just the beginning. How do we get there? A lot of what we do at the moment, because the children are not quite used to it, we say, okay, explain what you've done then. But they just give us a step by step. Oh, I did this, and I did this, and I did this, and I did this. Okay, but why did you do that? Why did you choose that method? Is there another method you could use? It's not about, okay, you can do that, let's put you on to some bigger numbers straight away. Let's put you on to something harder straight away. Harder numbers. It's, can we secure that concept, and can we actually go deeper into the learning? Okay, so the homework that we're giving is to support the learning that's been done in class. They give it a go at home, they reflect on what they've done in class, and then they bring it back into school, and then we all discuss it as a class, the children and the teachers together. That then brings into the reasoning, the extra problem solving, and it can then start as almost as a seed for new learning the next day. So that could be a starting point, it could be a task that we then go for our learning. So we feel that having this design of the homework gives it real purpose. And this is why we're doing that. Linked with one other very particular area of the curriculum, by Year 4, all children should know their times table facts up to 12 times 12. This has been going for a while. We're just making some little tweaks to it. So we are asking for your support at home, that when it's within the number bonds or within the times tables, the bronze and silver award that they get at the moment, the bronze award is when they can just do the tables in order, silver award in any order, and then the gold award in including division facts. What we'd like is for the parents, whoever's doing it at home with them, to sign off on the bronze and silver number award. Rationale behind that is because a lot of time gets spent in classroom that could be better used elsewhere. So we want to create a partnership. So can we take this on, these first two steps, and then the gold we'll assess in class. Then it will free us up to do more important things in, well, not important, but other areas of the curriculum. Okay, so it's just a slight tweak we're making to that. So number bonds, first of all, looking around Key Stage 1, when they've made it to that, they'll have a number bond badge. That will be a short test of 20 mixed number bonds, questions, addition, subtraction. Hasn't really changed that. Then they come on to their times tables. Later on, Andy's going to do a little bit of talk about how, as parents, and how we could teach the times tables and how we can actually support that learning. Later on, when they get to the gold times table, now the vocabulary is going to change a bit, and it might confuse you, so bear with me. The gold times table award used to be the gold sticker award. It's now just the gold award. And once they've done all their times tables, they get a times tables badge where they can do any mixed number, any times table questions in any of the times tables, 6, 7s. Okay. Once they've done that, and they've shown that they can recall all of those number facts from the times tables, we then have now introduced this Emerald Award. I just want to show you what the Emerald Award means. The Emerald Award will test children's application. So when we spoke at the beginning about just recalling number facts for fluency, okay, they might be able to tell you that 6 times 4 is 24. Great. But actually, if they really understand that, we can get this out of them. And all the links. If they know that 6 times 4 is 24, a rectangle has a length of 6 and a height of 4, what's the area? So yes, it's a different curriculum area, but it's using that number fact that they know. So it's not purely about being able to recall these. Once they do know them, that's great. But the next step we're doing with them is to actually apply it to different areas of the curriculum. So that will be the next step in the Emerald Award. Okay. The Diamond Award is new. We've put the Emerald Award in place so children can then have a go at applying the knowledge of number ones elsewhere. The Diamond Award is a very independent project that we're going to give children, probably looking Year 5, Year 6. Well, we are looking Year 5, Year 6, probably Year 6. And it's going to be a project where they're given a problem, and you probably won't have just one answer, you might have many answers, and they're going to present the project in a journal style. So it won't just be, here's my method, here's my calculation, done. It won't be like that. It's going to be much more of a, okay, well here's one way I did it, here's another way I did it. I looked at this area of maths and thought I could do it this way. It's going to be a prolonged project that won't just be a quick test. It's going to be something that they're going to really show their problem solving, the reasoning, all 3 areas of the maths curriculum. And that will be for the Diamond Award.
Is that over the course of the year? Or over the course of
No, so it will probably be a week, 2 weeks. If they need longer, they need longer. The task probably won't take more than 2 weeks. But when the children are ready for it, it'll be done on an individual basis. Some might want more time, some will be able to do it quicker. Okay, brilliant. Hand over to Andy Parkinson.
Just before I forget, it's a question about number bonds. Everything that's been done here in school is educationally research-based. So are you aware, because a little while ago it was something that came out to me, that if you're trying to embed number bonds for a young child, using 9 and 1, 8 and 2 and 7 and 3 are conceptually more effective than 6 and 4 and 5 and 5. I'm not going to go into the reasons why, but if all your examples are about 5 and 5 and 6 and 4, they won't get the concept of a number bond to 10 as quickly as if you start to use 8 and 2, 9 and 1 and 7 and 3. Of course you want to use all of them, but it's having that sort of knowledge about how children learn mathematically that is the important thing. And just mentioning number bonds just made me think about it. And so that's the big thing. It's all about research. Research is currently saying that we often think that you can't just watch something, you've got to be doing it. So we could do some rote times, no we're not going to do any rote shouting out times 10. That we can't just watch someone else do it, we have to do it for ourselves. Actually it's more than that. We've got to do it and then reflect, as Tom was saying, on what we've done. And that reflection and communication is the most important thing. I would like us to think that we're not actually teaching maths. I, as the maths advisor, would actually advise that we give up maths. We ought to be teaching thinking. We are preparing your children for jobs that haven't yet been created. And they're going to be using computers and calculators that will forever calculate in a far more effective way than we ever can. So they've got to be able to effectively reason and communicate that reasoning to someone else. So when you're looking to prove something, the first thing you have to do is prove it to yourself. Convince yourself that something's true. Then you've got to convince someone else that it's true. So maybe convince your friend, then convince your teacher, or your parent, and then you can convince anybody. And then if everyone's convinced, then you take it probably as truth. And that is an actual skill. So when you might think that your son or daughter has been asked to, well, can you reason that? What is the reasoning behind it? Yeah, I know, but I just know it's the answer, and I can do it quickly. Then there is a life skill that they're missing out on for not communicating that. Also, the quicker calculators don't tend to be the best reasoners in my experience. And the other thing is that when they then, my training, I'm actually more secondary trained, and I've been a secondary head of maths for many years before being a teaching advisor elsewhere and now in Jersey, is that there are gaps that we don't necessarily realise that we are creating because we haven't made people's reason earlier on. The big tragedy with the space shuttle that blew up many years ago was a problem with one of the O-rings on one of the fuel cylinders that had been created 2 or 3 years before and no one had picked it up. And so sometimes that can happen when we accelerate. And all the evidence now suggests that if we enrich rather than accelerate, we are much less likely to be having those gaps. The other thing is, for teaching in a mixed ability setting, is that I fundamentally believe that, and I'm going to put this word in brackets, virtually, in brackets, but I'd like to take it out, all pupils can achieve at mathematics at a high level. It is not, and it shouldn't be, the love it or hate it subject that we had as we went up through school. Oh yes, I was never very good at maths. And it's something I would ask you to be very careful about, just giving any perception that maths is hard. Maths can be hard. It should be hard. It should be challenging. It's a subject which the best mathematicians are working on problems, are being challenged by problems that they don't know the answers to. And that's what they find interesting. So your children will be given problems, and all children are being given problems that they can work on. Some of them, as they get it a bit more readily, may be doing a little bit more reasoning as and when they're ready for it. They will also be, the other analogy to the one that you were using, Tom, about going deeper, I would start to say, okay, what happens when you turn the air off? So they're happily diving around, thinking they're quite confident on this subject, and we're going to deliberately make it a little bit more challenging and a bit more difficult. How are you going to cope with that problem? But if it's a case of, I'm just going to give you some simpler questions, and if differentiation, it used to be more of, you have some simpler questions and you have some harder ones. Well, that does two things. It limits what these pupils can be doing. And it starts to say, yeah, but they're the brighter ones. They're the better ones. And I've actually seen it, and recently in another school, I was talking to a couple of year 4s, and I was asking them, well, could you tell me what 49 times 49 is? I don't think we've done that one yet. Oh, okay. Well, let's do it roughly. Could we do 50 times 50 to get an approximate answer? And approximate answers are really important because that's what we do all the time in real life, and yet we see as school maths as being right or wrong. Oh yeah, 50 times 50, yes, they were happy that was 2,500. And I had two of them, and there was a boy and a girl, and the girl had already told me that the boy was the best mathematician in the year group. He was the quickest and the best. And so I said, okay, can we use that fact then to what to do 49 times 49? And he straight came out, yeah, it's 1,681. And what he'd done very quickly, he'd done 40 times 40 and added 9 times 9. And she said, well, hang on, isn't it about 2,400? Because it would be about 50 less one way and a 50 less the other way. And she had seen him as the best mathematician. But his reasoning skills were actually not as well developed as her reasoning skills. Just to help out then with tables. And I confess that there's times when I've been at point 3 suggesting to pupils, well, you just need to know your tables as facts, in the same way as you might know the manager of Tottenham Hotspur, Mauricio Pochettino. You just know it, well, you know your own name. And you know your own name. Why do you know your own name? Because someone's told you for many, many years what your name is, and just by repeating it over and over and over again, you will get to know it. Yes, you do to a point, but we can learn more effectively. So there's 3 phases the current research is on learning your tables. Phase 1 is counting. You count up on your fingers. If you're going 3, 6, 9, 12, you're still counting. It's step counting, but it's still counting. You want to encourage maybe putting out an array of counters, and we talk about using concrete resources. There's a lovely example at the end there with petals and flowers, which I'll come to in a minute. If you can put it into an actual practical context, it's so important that you learn much more effectively when you understand the context of what you're doing. So that's concrete. Then we've got a pictorial representation here of the context there is each of these 4 children have got 3 crayons. So I can represent that with counters. And that's the first step of abstraction from a concrete problem to a represented problem, before you even get into writing it in terms of our numerals. Can we use some known facts? Well, if I've got it that way, I know that double 3 is 6 and double 6 is 12. So I'm working it out. I'm reasoning why it's 12 rather than knowing it's 12. And the more and more you do that, and if you have pictures around your house, a bit like that, I do apologise about it, I've recommended this time and time. You can make a little journey. You could have the 2 times 4 is here, and then 3 times 4 is over by the TV, and 4 times 4 is in the kitchen. They can make a journey, and they can learn the journey as they go around. And it helps that seeing it. But when you're talking to your children about your number facts, please don't just say 3 times 5 is 15, and we sort of learn it. We've lost the context, and it's much more difficult to learn. In that particular example, we've got 3 flowers, each have got 5 petals. And there's a fundamental difference between that question and when you're doing addition. If I had 3 flowers and 2 flowers, then I've got the same thing, in the same way as Tom was talking about 1/5 and 3/5. I'm adding fifths, and sometimes writing it in the word fifths. It takes it into a noun of what I'm adding together. When you're talking about multiplication now, I'm talking about flowers and petals. I'm talking about 2 different things. So we say it, and if we say it in context, we learn it more effectively. So 3 flowers, each with 5 petals, will mean that I've got 15 petals in total. And if you go to that slightly deeper level of saying it, rather than just 3 times 5 is 15, then you start to learn it and know it as a fact. And then your fluency will start to come. And I just echo what Tom was saying, in that fluency isn't speed. A fluent speaker wouldn't be expected to talk quickly. They would be expected to communicate effectively. And so we shouldn't be seeing fluencies. Yes, we don't want to be going to the other end where 3 5s. Hang on, yeah, I know that one. So yes, that is an evidence of not being fluent, but it's not about I can do 30 multiplications in 5 minutes and I'm therefore the best mathematician. Maths is very little about calculating and much more about thinking and reasoning. So I really do commend the new approach would be the mixed ability teaching that allows everyone to feel enabled and they've got a growth mindset that they can achieve. Because the other thing about, if I give this half of the room the easy work and this half of the room the hard work, this group think, well, we can't do maths. Maths isn't for us. We're no good. And we can, the school have got in place for things to help stretch and challenge, and so the person who thinks I can comfortably do that, well, there'll be a little twist to it. And can they do the twist? And keep them thinking. And if they're thinking mathematically, they are learning. And the school have got a very good approach to bring out, and that's why they're bringing it out. The new curriculum, the 2014 curriculum, is a tougher curriculum. As a secondary teacher, and some of you might have other sons and daughters at a higher level in secondary school, first year of the new GCSEs this year, awful lot of, not just on Jersey but in the UK, about what the grades are going to look like, and it's a much harder curriculum. The things that used to be at higher level GCSE are now at foundation level. Unless we start doing this now within the primary sector, we're not going to be ready. The fruits of this will be seen in a few years' time as your children come up through GCSEs, and hopefully we'll have an engagement in maths that we'll want to see them take it further, maybe into A-level and beyond.